Section 7.6, Phases of Matter. By now, you all should know that matter can exist in 4 different phases. There's what we call the solid phase, things like ice, iron, rocks. There's the liquid phase, which is things like water and mercury, alcohol. There are gases like water vapor, carbon dioxide, propane. The 4th phase of matter is the one most people are not as familiar with, and this is the plasma phase of matter. And this is when you break atoms down beyond the bonds that hold the electrons to the protons. And so what you basically have are positively charged nuclei and electrons flowing around. There are no real atoms there. This is a phase of matter that you only really find in stars. Solids are structured in a way that all of their atoms are connected to one another. That's what makes them solid. That's why when you hold it and you press down on it, it feels like a solid structure because all of the atoms are aligned in a particular way. So these atoms cannot move very easily. If you increase the energy of these particular atoms by, say, exposing it to heat, the molecules will start to move faster and faster and faster. And eventually they'll break apart those bonds that make it solid. And at that point, those molecules will still be kind of stuck together, but they won't be as joined. And then you have a liquid. You've melted the solid and made a liquid. If you continue to add energy to those particles, eventually they'll break free of each other and start to fly around the room or whatever container they're in. And you've added enough energy then to change from a liquid to a gas. So anytime that you add energy to a particular object, by adding energy, you can cause objects to change their phase. Any solid, if you heat it up enough, will turn into a liquid or a gas. And if you heat all of the atoms up enough, they'll all turn into plasma. But again, that's why that does need to occur inside of stars. So there are ways that substances can change phases. And that's what we're going to talk about for the rest of the chapter. The first way is by means of evaporation. When you have a liquid that changes to a gas at its surface, we call that process evaporation. What happens is you have molecules inside of the liquid that hit each other, and eventually, at the surface, one of those molecules sitting right at the top gets hit, and it flies away, and it becomes a gas. And as this happens over time, things evaporate. So many liquids will just naturally evaporate over time. For example, if you take a cup of water, don't put a lid on it, but just a little cup of water and stick it in a closet or a cabinet somewhere, and then go back in about a week, you'll notice that the water level is down some, if it's not completely gone. And that's just because that water over time will just evaporate. What's interesting is when the gas molecules leave, they're actually moving faster because they got bumped and bumped away. Those molecules are moving faster than the ones that are still in the liquid. And this causes the average kinetic energy of the liquid to go down. So by the gas molecule leaving at a faster velocity, the temperature of the liquid goes down. Evaporation is actually a cooling process. This is why when you sweat, your body's cooled down as the sweat evaporates. Here, where it's very humid, you find that your sweat does not evaporate as quickly, and you feel very, very hot if you're outside. If you're in a more drier climate with less humidity, your sweat will evaporate more quickly. Sometimes a substance can skip straight past the liquid phase and go to a gas. This happens with frozen carbon dioxide, which is dry ice. If you have dry ice just sitting out in a room, it looks all smoky. This is because it's skipping the liquid phase and going straight from being a solid to being a gas. That process is known as sublimation. Under the correct conditions, water will also do this as well. The reverse process to this is when a gas changes to a liquid, and this is known as condensation. So here you have a liquid, and a gas molecule strikes the surface of the liquid and hits it in a way that it gets trapped. The amount of liquid goes up because now there's more molecules there. And the kinetic energy of the liquid goes up because it just added a faster moving gas molecule. And so condensation is actually a warming process. It occurs when things are warming. For example, if you take a hot shower on a cold morning, condensation will form in the mirror. This occurs due to the change in the temperature of the air. If you have a paper cup or a cup you get from a fast food restaurant and you have some ice in it, as the ice melts and the drink heats up, you will find condensation on the outside of the cup. This is not your drink leaking through the cup. That will happen in paper cups, but you have to leave it for days. What's happening is that the water in the air is being condensed on the outside of the cup as the drink warms up. And again, in a very similar way, this is why sometimes it feels hotter in a place like the Mississippi Gulf Coast than it does in a place like Nevada or out west. Because with more moisture in the air, it's harder for water to evaporate and condense because the water resists changes to temperature.